John Nicholson, Senior Technical Marketing Manager for VMware. Thank you very much for being here today, John.
Hey, glad to be here.
You can take it away.
Oh, okay, cool, awesome. So my name is John Nicholson. I'm a Senior Technical Marketing Manager with Storage and Availability at VMware. My core focus is on VSAN. It's what we're going to talk about today, how VSAN delivers VMware's hyperconverged solutions. So a quick first thing I want to do is level set of what virtual SAN is. And how virtual SAN works is we have two primary architectures. We have the traditional hybrid, which we introduced in ESXi 5.5 Update 1. This was a great architecture, and it was basically we leveraged flash for read and write caching, and we separated that out from cheaper, lower-cost magnetic capacity devices. So all writes would be acknowledged to those flash devices. 30% of those flash devices were reserved for write cache, and the other 70% was for read cache. So we were able to get amazing all-flash-like performance, but at a much lower cost price point. We were seeing, 40,000 IOPS per host we have here on the slide. I've even seen customers get a lot more than that, and just amazing results in performance. Starting in 6.0, we also introduced an all-flash design. For this, we completely rewrote our caching algorithms and came out with quite a new bit of code and back end. What we do here is we still use two different tiers, but they're both flash. And what we do is we have a high endurance, typically a smaller flash device that will absorb the writes. And this, our caching layer is 100% devoted to writes. And this will acknowledge the writes, and hot data will be overridden here. And as data goes cold, we will destage it down, and it will fall down to the capacity tier. We're able to use much lower cost capacity devices. In fact, just looking recently at pricing, we have some devices that are certified that are as cheap as 52 cents a gigabyte. So there's some really low cost, but still enterprise class devices that you can use for this. And we're seeing an increased uptake. And the all-flash, obviously, can deliver better performance from just a raw number of in-out operations per second, but it also has the advantage of delivering very consistent sub-millisecond latency response times. We recently were able to pass a HANA, SAP HANA, in-memory database performance test. We're still working on that certification, but we're able to pass the performance requirements using an all-flash vSAN. So we're able to hit some of the most exotic of workloads. We've got some technology, which I'll get to here shortly, that really helps the all-flash become much more competitive from a cost basis and start to actually displace hybrid in a lot of cases. So we've got, first off, just from a vSAN, we've got three primary delivery vehicles for it. We've got kind of the build your own, where we have an HCL. We have certified components that have been verified by our vSAN validation lab group. And with that, we also have ready nodes, which are pre-collections and kind of pre-sized together of memory, CPU, flash, and capacity devices. We've got those from all the major OEM vendors. We really wanted to make sure when we implemented vSAN, one thing we wanted to maintain was choice. We want you to be able to work with the existing vendor you have relationships with, or you enjoy their support, or the cost value proposition they bring. In addition to those ready nodes being purchased in that way and you deploying it, we also have some vendors that are working on being able to deploy a pre-installed vSAN option. The next step up is we also have engineered appliances. And this is a turnkey appliance with a wizard for automated deployment, so you can be within 15 minutes, have your pre-configured cluster and everything kind of ready to go. The next step up from that is, this is in limited deployment, but it's coming out here soon for general deployment, is what we call Evo SDDC. And what SDDC is it's software-defined data center. And so really with that term, what we're trying to encompass is VMware really revolutionized compute and how we think of memory and CPU utilization in a data center today by virtualizing just traditional workloads. And we want to bring that abstraction and that efficiency not only to compute, but also to networking in the form of NSX, which is bundled with SDDC, and also with storage with vSAN. So that's kind of that packaging together, and that's aimed at people who are looking to purchase and acquire virtual SAN at kind of a rack scale and turnkey type solution. So getting into some use cases, virtual SAN is the most widely adopted hyperconverged software product on the market. We have over 3,500 customers we just announced last week for earnings. And within those customers, we've got really exciting use cases and adoption. We've got a white paper out there and a blog post on Duncan's blog talking about a North Sea oil exploration company who actually put virtual SAN clusters on oil rigs because they wanted self-healing turnkey deployments that could be scaled down very well. We've also got cases of people using on submarines with 2 data centers on there and doing replication between them. I can't get too much into the specifics of that, but virtual SAN is being deployed for mission-critical workloads. And we did some polling and looked at what customers were using it for. And beyond the initial adoptions, we saw a lot of VDI, a lot of test out, but we also saw the majority of our virtual SAN customers today are using it for business-critical workloads, things like online ticketing and transaction systems for airlines, things that if they go down are going to cost a lot. So it's interesting to see that customers are using it across the whole area. And one thing to keep in mind that while virtual SAN can scale up, you can certainly have a 64-node cluster. It also scales down. You can have small 2-node clusters for remote office branch operations. We now can offer that. So it really can, if you've got environments where maybe you just need a small 4-node cluster for a DMZ or for management or for a second site, it's a really flexible solution. And just to give you an idea of how simple it is, we have a phrase we like to use, radically simple. Here's the setup for virtual SAN 6.2. This is within the existing vSphere web UI. And when you enable it on a cluster, if you're doing all flash, you also have the option to enable deduplication and compression, which is a single option for the entire cluster. We wanted to, we did some really cool optimizations that I'll talk about. We wanted to make sure the performance was there so that when you turn this on, you didn't have to worry about compromising. And you could just turn it on in an all-flash environment. You also will select in this environment whether you have a 2-node, so you've got a witness involved, a stretch cluster type environment, VSAN supports stretch clusters, or if you're using fault domains. With fault domains, what that means is you've got multiple cabinets or multiple pods, and you want virtual SAN to make sure you can survive the loss of an entire rack. That way, if Tim, the destroyer of network uptime, trips over a power cable and takes out a cabinet, virtual SAN will keep on operating. So one thing to keep in mind is virtual SAN, it works with the storage-based policy management. So if you've worked with vVols, or you've worked with VASA, you'll recognize some of these things. And what this is it within vCenter, it'll talk to vSAN and look at what its capabilities are. And in this case, we've got a policy we're creating here. We can adjust things like stripe width or cache size. We can also set IOP limits, adjust checksum settings or space reservations, or even say whether we want to do RAID 1 mirroring or RAID 5 type protections. And these policies can be applied programmatically through APIs or automation, and these policies can be applied at a very granular level. It can be applied to a single object, which in this case would be a single VMDK, a single virtual hard drive. So imagine if your existing array, you could pick out individual virtual hard drives and redefine the RAID policies on the fly without disruption. That's the kind of power we've got here from the capabilities. And if you're used to vVols or you're working with vVols, that's the exact same interface. So a quick review of the product, where we are and where we've been. With Virtual SAN 5.5, we had our initial product. It didn't necessarily have all the bells and whistles, but it was fast and it was reliable and it worked. With 6.0, we announced all flash support. We also, if you've worked with traditional VMware snapshots, you know there's some performance limitations. You can't leave them open for a long time or problems. So with Virtual SAN 6.0, we actually implemented a native file system snapshot offload. So if you're creating snapshots for the purposes of backups or things like that, you're not going to take the huge performance hit that you previously would have with a normal VMFS redo log. We introduced built-in health UI. We've got lots of automated monitoring operations. We extended support for all flash. In 6.1, we introduced Stretch Cluster, and that works with having 2 sites. Reads are served locally, and you can stretch that up to 5 milliseconds. And then also in 6.1, with a native replication within vSphere, if you're going vSAN to vSAN, you can hit a 5-minute recovery point objective. So for those applications that you need to keep up to date between 2 sites, you can do a local Stretch Cluster. And then when you need to go beyond the 5 millisecond limitation to a geographically different third site, you can use that 5-minute RPO window with replication. And that replication is compressed for bandwidth efficiency. We also introduced 2-node robo, and how that works is you run a virtual appliance as a witness. And you run that back at your primary data center, and that can be up to 500 milliseconds away. So I've had a lot of conversations with people within, say, state governments or retail and grocery chains and people or oil service companies who have hundreds or thousands of sites, and adding that third host for a cluster adds a lot of cost and added operational just environment power and cost and things like that. So they want to be able to scale down to 2 nodes. And we can do that. We can do that safely with a remote witness. We've also extended the health monitoring to where there's built-in health tests. So you can actually, VSAN itself within the health UI can actually basically do a burn-in of itself, create disks. You can make sure there's no anomalies. So that way when you get to day 1, day 2 operations, you're not finding that you've got a host maybe with a bad flash device or something like that. And then in 6.2, we've added a bunch of new exciting features, which I'm going to get to here really quickly. So the most exciting feature you get a lot of feedback on is deduplication and compression. And what we wanted to do here was really implement this without compromise. And there's 2 ways traditionally to do deduplication or compression. And that's inline, where you do it up front, and that adds some latency or requires dedicated hardware, things like that. Or you can do it post-process, but that involves a performance hit. It involves a lot of extra CPU in terms of having to pull data back and forth and then run kind of a defrag process called garbage collection. So we wanted to strike a balance. And so what we do is, as I mentioned, that 2-tier, we have the initial flash device, which is the write buffer. It's the high endurance. And a lot of data in an environment has a lifespan of a NAT. It lives for a couple seconds and it's overridden. So if data is overridden, we're not going to waste CPU compressing or deduplicating that data. And then as that data goes cold, as it ages out of that write buffer, we read it into memory once. We run a SHA-1 hash. We check for if that data is unique. And if it's not unique, we save a pointer and we're done. We're not going to waste compression on data that's not unique. And then following that, we run compression, which is LZ4, a very fast, efficient industry standard compression algorithm. And we see if we can get that block from a 4 kilobyte size down to 2 kilobytes or less. So we're not going to save data if it doesn't compress well. And so by doing these because we don't want to pay the CPU cost on rehydrating it later. So by doing these techniques, we're able to make dedupe and compression basically a checkbox to enable for the cluster without having to have lots of sub-decisions about which blocks the dedupe post or pre or other processes. We wanted this to be really simple. Our deduplication is also done with a 4 kilobyte block granularity, which is as good as it gets in this industry. And while some other people may use an 8 kilobyte or 16 kilobyte, we find the 4 kilobyte, by being much smaller, it's more likely to find duplicate data. And we scan all of the data, not just a fraction of it. We've also implemented, for all flash only, we've got a RAID 5 and RAID 6. And with these features, again, when we looked at implementing them, we saw that there were lots of corners we could cut to basically, ship something. But we wanted to make sure they were something that we would recommend people could use and use well. And so that's why they're all flash, because we understand the overheads associated with it. With RAID 5, this works on a 3+1 system. So instead of a 20 gigabyte VMDK using 40 gigabytes of traditional mirroring, and now we'll use only 27 gigabytes. RAID 6 uses a 4+2 system. So, and it has that 20 gigabyte VMDK would now consume only 40 gigabytes instead of 60. So, and the great thing with the RAID 5 and RAID 6 is they can be combined with the deduplication and compression. They are implemented, though, on a policy basis. So you could have individual VMDKs or individual VMs, or you could use policies to automate groups of virtual machines to use RAID 5 or RAID 1 or RAID 6, depending on your availability requirements. And one thing also to consider is while deduplication and compression, that's a variable space savings, RAID 5 and RAID 6 is savings you can count on. Even if your data is already deduped or compressed, this is from a sizing perspective. And what we found is looking at, again, the raw price of flash with major vendors out there. Duncan's got a great blog about this, and we've got a space efficiency white paper that discusses these pricing trends. The cost difference between capacity optimized flash and 10,000 RPM drives was really already so close that by adding a good RAID 5 and RAID 6 implementation and deduplication compression, we're actually seeing all flash come in cheaper than using 10,000 RPM drives in a hybrid configuration. So another question that we had a lot of people ask was about performance and capacity monitoring. They're used to having low level, they want to be able to look at what was going on in the environment. And while we do have plugins for vRealize operations, we also wanted to have it just native to the existing UI. So, and we've extended this initially as a plugin. It's now no longer a plugin, it's now baked in. We have performance monitoring, and this performance monitoring can either be bottom up, so you can be looking at individual devices, looking at, if an SSD's got latency issues or things like that, it'll give you warnings. But also top down, we can look at individual virtual machines and look at their cache hit ratios, look and see if they're hitting an existing IOP limit in the environment, or some type of throttle in the environment. And so we wanted to make sure that we're not, you've got that visibility end to end. The other thing is with capacity, we wanted to make sure people could understand where that space was going. One thing that previously our swap in VMware, which is by default reserved or thick, is in 6.2 we gave you the option at host level to make your swap or your space used for memory that's traditionally reserved for memory overcommit, make that thin. So if you're in an environment where you don't do memory overcommit, it's actually a lot of savings. And so being able to visualize and see whether space is going to snapshots or things like that, as well as look at the deduplication and compression and overheads, we wanted to make sure we had great drill downs. One thing I do want to highlight on the performance monitoring is we actually have built-in performance tests. So you can test network to network between hosts. So if you're setting up a cluster, maybe a VLAN wasn't trunked correctly, maybe you've got a bad switch link or something going on in your environment. Before you get to day 2 operations and discover a problem, you can actually have burn-ins be run. And this is all, again, just baked into the existing vSphere UI now, and make sure all the hosts are reporting consistent performance and within expected outcomes. This really helps people make sure from going into day 1, day 2 operations that they're confident about their virtual SAN environment. And again, I've got some examples here. You can look at individual. We've got dozens of health tests, and we keep extending this. And this is often driven by GSS or customer queries. So this is actually being updated asymmetric to the general vSphere releases. So we're really trying to drive this to where customers have quick visibility even into low-level things without ever having to go into a log file or a CLI or any type of advance. They can see what's going on in their environment. In this case, I've got a view here. You can even have it test object creation and things like that, as well as the network test, as I mentioned. So from an application standpoint, vSAN is ready for all business critical applications. Again, we have customers using it for some very important workloads. From a Microsoft standpoint, we support Exchange. We support Exchange DAG. We have reference architectures around these things. We also support SQL, always on availability groups for clustering SQL. For Oracle, we support Oracle RAC. In fact, there's actually a VMware validated design out there, I believe, using Oracle RAC and vSAN Stretch Cluster. So if you want to cluster while you cluster, we're ready for that. With SAP, we support the core application set, so all the core apps, NetWeaver, things like that. One exception here is HANA, and part of that is that SAP currently does not allow, they do not have a certification process at all for any type of HCI infrastructure. And we're actually working with SAP to try to define what that's going to look like. That said, our performance team has actually done testing and been able to pass the benchmarks required using an all-flash vSAN. We're able to deliver 7-millisecond latency. And since SAP HANA is really one of those exotic, it's an in-memory database, one of the most demanding workloads possible, it really shows the capabilities that vSAN is able to deliver. By being baked into vSphere and being baked into the kernel, it's able to have priority access to the CPU scheduler. It's able to make sure it can deliver very consistent latency results. And on the case of VMware Horizon and VDI, Virtual SAN, obviously there's some bundle license deals. So you can have a nice pay-per-user, nice clean scaling. But also from a performance standpoint and from a simplicity of deployment, I came from a partner, I came from a customer. I actually deployed Horizon on vSAN. And I was so amazed that I can honestly say if you're deploying VDI, if you're deploying Horizon on anything that's not vSAN, we've fundamentally failed to communicate something from a cost, from a performance, being able to just add nodes and you scale out disk performance with your compute requirements. It's really amazing. There was a storage field day 9 was recently, and there were some performance benchmarks done for VDI, and even adding the RAID 5 and the dedupe compression and all of that, the VDI CPU usage went from, I believe it was 0.8% to about 2.2, turning everything on. So while some of the other VSA products out there may use 4 or 8 CPUs, using a third or as much as half of a host for CPU, vSAN is very efficient on CPU usage. Because while it's great to have very fast storage, the end goal of vSAN is not just for vSAN to exist and process storage. It's to help you consolidate virtual machines and help you consolidate your data center. And so we leverage the strengths we have to be very efficient, and like I discussed, the deduplication. We try to use every trick we can to keep that utilization as low as possible so you can get as great of a return on your investment. So wrapping up here, We've got some great options if you want to try vSAN. We've got it in the hands-on lab. We've got the new 6.2. There's also a feature walkthrough you can click through if you just want a quick tour of what the interface looks like. That hands-on lab, by the way, that spins up in VMware's cloud an actual vSAN cluster for you to set up and configure and play with. It's not on Rails. You can break it. You can blow up the lab and reset it. There's also just great trials across all of our products there. There's obviously, we've got free downloads and evaluations, and if you reach out, we've got a vSAN SE team who can help you get set up for proof of concepts. The third option is we have a vSAN assessment tool. This is a really cool tool. And what this does is you deploy a virtual appliance, and it looks at your environment. It actually uses what's called vSCSI trace, and it looks at a raw block granularity on how random your data is, on how many blocks are actually hot to help you decide whether hybrid or all flash makes sense, as well as help you understand what your workload's doing. That's a free assessment that both our partners can deliver, as well as also our SEs can help you with. So give us a call and we'll help you with that. Again, my name is John Nicholson. You can follow me on Twitter, _signal. We're always looking to help people adopt vSAN. So, have we got any questions, Chris?
Hey, John, thank you very much for the presentation. This is Scott, and we do have some questions for you. Are you ready to take people's most burning questions that they have about vSAN?
I'm excited about burning questions, but not always excited about things burning, if that makes sense. So.
I understand. Well, you just talked about blowing up servers or blowing up your lab, so I thought you'd be into that.
Fair enough.
From a person that I know personally, actually, the question is, the specific question is, does vSAN support RAID 50? So he says we currently mirror data centers and want to run the enterprise with one, with either data center offline. I imagine they're talking about, some VR real-time capabilities. Can you explain how vSAN might help in that kind of a scenario?
So one thing to keep in mind is vSAN does not use local RAID in the host. It actually uses pass-through, and if you happen to have a RAID controller that doesn't support pass-through, you basically put every drive in RAID 0. vSAN does what's called RAIN. It's redundant. It distributes the RAID basically across the nodes, and that's why the same disks can actually have different RAID levels for different virtual machines. So you could have some virtual machines that were at a RAID 5 and others that were RAID 1. Now, if you're trying to protect between data centers, you could do a stretch cluster with vSAN, or if maybe your second site is a passive site that's farther than 5 milliseconds away. I live here in Texas. It's more than 5 milliseconds between all of our cities. You could always use the vSphere replication, which is built in and baked in. And that leverages the vSAN's native capabilities to get you as close as 5 minutes to the last good copy of your data.
Excellent. Thank you. The other question I think is an important one, especially given how quickly VMware has been releasing new versions of vSAN, and it's how's the upgrade experience been for people as they move from to new versions of vSAN and add new features?
So one thing to keep in mind is vSAN is not a scale-out file system. And so previously, if you worked with scale-out file systems, if you want to make giant changes to them, you want to change the block size, or you want to write a new snapshot system, you typically had to evacuate everything off the file system, and it was kind of a disruptive process. vSAN's a scale-out object store, so each disk group and each host is actually its own file system. So when you do a major upgrade, say from 5.5 to 6, or from 6 to 6.2, where you choose to upgrade the file system, which you can do when you want, what it actually does on the back end is it does a rolling movement of data between hosts through the cluster. And you can define that as go ahead and make a new copy and protect that data first, or just maintain one copy for availability. That's actually an option that you have when you make that upgrade. But the cool thing is we've been able to do things like change block size that other array vendors have forced complete evacuations of their array for without disruption.
Awesome. And there was a question about SSDs. When sizing SSD in an all-flash vSAN, so the cache, the slides changed.
So if you're doing an all-flash, we typically recommend a 10% ratio of the high endurance to the back-end capacity. And that's based on there's a good blog Cormac Hogan has out there. It's based on some kind of voodoo math on approximate overwrites and the differences and how much data will get destaged versus just get it overridden, as well as the endurance differences. Note the HCL and the ready nodes, they validated, and there's certain drives that are validated for capacity and some are for cache.
Sounds good. And with that, we are on to our next prize giveaway. Thank you very much, John, for being here today, and thanks to VMware for being a part of today's event.
All right. I'll go ahead and answer the questions remaining in the queue offline. So thank you.
Thank you very much.